Functional testing is an important part of the software development process, as it helps to ensure that the software is functioning correctly and accurately. Functional testing verifies that the software meets its specified requirements and works as expected. It checks for errors and bugs in the code, ensuring that the software behaves as it should. Functional testing is performed by subject matter experts, who have a thorough understanding of the system being tested. These individuals are responsible for writing test cases that simulate user interactions with the system in order to discover any problems or bugs. These test cases can range from basic to complex, depending on language used, type of inputs and outputs, etc. Once these test cases are written, they are executed on the system to measure performance and uncover any errors or inconsistencies. When performing functional tests, it is important to consider all potential use cases when designing tests. This means that all input combinations should be considered in order to accurately simulate user behavior. Additionally, all outputs should be validated to ensure that they meet specifications and match expected behavior. The goal of functional testing is to identify problems before they occur during production or in the field usage. This helps save time and money associated with bug fixes and product support later on down the line. It also ensures a quality product experience for customers by eliminating any potential risks associated with using faulty software. The process of functional testing starts with creating detailed requirements for each feature of the software application or product being developed. These requirements serve as guides for developers when building out their solutions, as well as for testers when validating functionality during functional tests. Once these requirements have been established, testers can begin running scenarios against them in order to identify any errors or inconsistencies that may exist within the application's code base or output results. When running functional tests, it is important to consider both positive and negative scenarios in order to cover a wide range of possible outcomes when users interact with the system being tested. For example, if a login page requires users to enter their email address and password correctly in order to gain access, positive scenarios would include valid email/password combinations, while negative scenarios might include incomplete data entries, missing fields, or invalid characters/numbers/symbols entered into either field instead of actual data values, like an email address. It is also important to keep track of any failed tests so that they can be referred back to later on if needed, for example if a bug occurred somewhere down the line. Additionally, results from all successful tests should be documented so that developers can reference them later on if needed when fixing issues or making enhancements/improvements further down the line following launch day deployments into production environments or other application usage situations outside development environments entirely, such as mobile apps. Finally, keep track of all test cases used throughout your testing efforts so you can refer back to them at any time. This will help save time by not having to start over from scratch every time you need a refresher on test cases used previously during past projects/applications developed by your team members here at Company Name. Functional testing is an important element of software development and maintenance. It helps to ensure that the software functions as designed, and that it meets the user's expectations. Functional testing is performed to validate the behavior of the system, by comparing it against predefined requirements. It is a black box testing approach, which means that testers are not aware of the internal workings of the system. To begin with, functional testing should be carried out for every major change in the system. This should include feature changes, bug fixes, or any other modifications. It is important to note that functional testing should cover all use cases and scenarios applicable to the system. This should encompass both normal and edge cases, ensuring that all possible user inputs are considered. When performing functional testing, it is essential to have well-defined test cases with clear objectives and expected results. This will help testers to focus on critical areas of the system and identify potential issues faster. Each test case must include steps for setting up a particular scenario, input data requirements, as well as expected outcomes for verification purposes. Testers must also track any test case results for future reference or regression purposes if needed. Functional tests can be divided into two main categories: manual tests and automated tests, also known as scripting. Manual tests involve human testers manually executing predefined test cases while observing results in order to decide whether they pass or fail according to their specifications. Automated tests create scripts that can execute large numbers of test cases unattended over extended periods of time and compare them against predefined criteria in order to detect any discrepancies or errors in the system's performance or functionality. It is also important to consider performance when performing functional testing, as this will give an indication of how quickly users can access and interact with a given application or system. To measure performance, testers can use different tools such as Aptometer, JMeter, etc., which provide a range of metrics such as response time, throughput, etc., which indicate how well an application performs under certain conditions such as peak loads or unexpected user interaction scenarios. Finally, it is worth noting that functional tests are not a one-time event but rather an ongoing process throughout the lifetime of an application or system. Once identified issues are fixed by development teams during sprint cycles, functional testing should be carried out once again in order to ensure complete coverage. In addition, regular reviews/audits should be carried out by QA teams in order to keep track on changes made over time. In conclusion, functional testing is a key element when it comes to software development and maintenance. By validating behavior, ensuring good performance under different conditions, tracking changes over time and validating all use cases, organizations can be sure that their systems meet their users' expectations at all times. Functional testing is a type of software testing that ensures that an application behaves in accordance with the specified requirements. It is used to ensure that all functions of an application are performing correctly, providing the desired results. Functional testing focuses on the business and technical requirements of the software, as opposed to its source code or internal structure. It is usually performed by testers who have knowledge of the specific system being tested, as well as an understanding of how users would interact with it. Functional testing has many advantages over traditional non-functional testing methods. For example, it can quickly identify if there are any errors in the system's logic or design, allowing for quicker resolution and reduced costs. Additionally, it can uncover user interface issues or problems with workflow. By performing functional tests early on in a project, developers and testers can catch errors before they become too expensive and time-consuming to fix later on. There are several different types of functional testing which are typically used during the development process. The most common types include 1. Unit testing. This type of functional test is performed to ensure that each individual unit, or module, in a system operates correctly by checking its inputs and outputs against expected results. This helps ensure that each module behaves as expected even when combined with other modules in the system. 2. Integration testing. This type of functional test is aimed at ensuring that all components within a system work together as expected and do not interfere with one another's functionality or cause any unexpected errors. Integration tests typically involve multiple modules or components working together simultaneously and can be used to identify compatibility issues between different parts of a system prior to release. 3. System testing. System tests evaluate the entire software product, using realistic use cases to simulate how users will interact with it in real-life scenarios. These tests help identify errors that may not have been caught by integration or unit tests, such as usability issues or performance problems under certain conditions. 4. User acceptance testing. UAT involves users actually using the product prior to release, providing feedback on its usability and functionality from their perspective and noting any issues they encounter along the way. Example, missing features. This helps guarantee customer satisfaction once a product comes out into production environments so developers can address any outstanding problems before final delivery to customers/users/clients, etc. In sum, functional testing provides a range of advantages over traditional non-functional testing methods since it can quickly identify potential errors early on in a project lifecycle while simultaneously guaranteeing customer satisfaction upon product release into production environments by uncovering usability issues along with performance problems under different conditions prior to final delivery, into customers' hands/use cases, etc. Therefore, making sure your organization implements an effective functional testing strategy for development projects should be given high priority for success. Functional testing is an important part of the software development process. It is used to verify the functionality of a system or application and to make sure it meets its requirements. To do this, there are a number of tools available that are used to carry out functional tests. Let's take a look at some of these tools and how they can be used in functional testing. The first tool commonly used for functional testing is automation testing frameworks. Automation testing frameworks allow developers to create automated tests that can be applied on any part of an application or system. These tests are designed to simulate real-world scenarios and can verify if the system works as expected when exposed to different conditions. Automation test frameworks make it easy for developers to create repeatable tests, which helps improve the quality of the software and reduce costs associated with manual testing. Another popular tool for functional testing is unit testing frameworks. Unit tests are small pieces of code written by developers that are designed to test individual functions within an application or system. Since unit tests generally don't require any external input, they can be run quickly and efficiently. This type of test ensures that each feature, module, or component works correctly before being integrated into the larger system or application. In addition, there are also specific tools available for different types of functional testing such as regression testing, integration testing, and acceptance testing. For example, regression testing tools allow you to quickly identify bugs in existing code by running automated tests against older versions of your software or system, while integration test tools help you detect potential problems when combining different components or services together into one system. Acceptance test tools enable you to easily create end-to-end scenarios that simulate real-world user interactions with your product or service and validate that everything works as expected in production environments. Functional testing also requires other types of tools such as bug tracking systems and performance measurement systems, which enable developers and testers to record bugs, track progress, and analyze performance metrics during their development process. Bug tracking systems allow developers and testers to quickly identify errors in their code, which helps them optimize their applications more effectively, while performance measurement systems provide insights into how well an application performs when subjected to various use cases from real customers or users. Finally, there are additional services available like cloud providers, which offer additional functionality such as virtualization environments where applications can be tested without having physical hardware on site at your location, as well as online load balancers, which help distribute traffic more efficiently across multiple servers, thus enabling smoother user experiences no matter where they are located geographically speaking. Overall, there are many diverse options available when it comes to selecting tools for functional testing, depending on what type of project you're working on and what your exact needs may be related to verifying functionality in your software or applications before releasing them into production environments. So make sure you do thorough research before investing in any specific option.